In this video, I'll be helping you with the ALEKS problem type called graphing a hyperbola centered at the origin ax squared plus by squared equals c, where we're given a hyperbola to graph, but it's not in standard form. So we're going to rewrite this equation in standard form. And for a hyperbola, I know that standard form has the first fraction over a squared minus the second over b squared equals 1. And our numerators will either be x minus h squared and y minus k squared, or with the y minus k squared first and the x minus h squared second. And at this point, we can't tell which of these this will be, but we do have subtraction and both of these variables being only squared, so we won't need to complete the square. And to put this in standard form, the first thing I notice is that this right-hand side needs to be 1, and I can accomplish that by dividing each term on both sides by 4. This will give me that 1 on the right-hand side, and on the left-hand side, my first part is x squared over 4 minus, and then these 4's cancels, so I will write this as y squared over 1. I now have standard form, and I can tell that this is the version with the x minus h squared first and the y minus k squared second. And since the leading variable is this x term, I know that this hyperbola will have a horizontal transverse axis and opening left and right. I can also tell that my h and k's, which are the center. In this example, I'm not adding or subtracting anything, so technically I'm subtracting 0 from the x and subtracting 0 from the y, so my center is going to be the origin, 0, 0. So we can go ahead and graph that part. And from here, I'm going to start putting together my rectangle, where I use the letter that's under the x term. Here that's an a. That denominator is a squared, so a squared is 4, a is 2. And since it is under the x, I will go 2 spaces to the right and 2 spaces to the left to get the edges of my rectangle. And then I'll look under the y variable. Here, b squared is 1, so b is 1. I would go up 1 unit and down 1 unit from that center. Connecting these points gives me our rectangle, and then our asymptotes through the center and the corners give me the asymptotes. And again, since the x term is leading, I know that we have this shape left and right, so our vertex will be on the right-hand side here and approaching asymptotically to our asymptotes. And the same on the other side. This is our vertex, and we're approaching the asymptotes. So this would be the graph of this hyperbola.